Okay, so we're talking about two new concepts. One of them is called Rolle's theorem, and the next will be the much better version. It's called the mean value theorem. Um, Rolle's theorem basically says if you have a function f of x, um, if f of x is, first off, if it is continuous on the closed interval a, b, and so basically that it fills in all the points and a and b exist and so on. And also that it's differentiable on the open interval a to b. So there are no places in the middle that don't exist or something like that, as long as everything seems normal on that range. What it says is that if f of a equals f of b, then there exists a value c such that f prime of c equals 0. Well, that may seem like a lot of words and maybe slightly confusing, but in reality, it's saying something pretty basic. What it's saying is that if I had a graph and I pick a couple of numbers, so let's say we have A and B, and we have this graph where they are the same value at A and B. So that's what these being on the same line here means, that f of A equals f of B. What it says is that if it's continuous and differentiable, so basically that it's smooth and all the holes are filled in. So it doesn't matter, what I do to it between now and then. But that they connect and that it's smooth. So it says then there exists a value c. So at least one, too. I mean, it could be more than one, but at least one value c, such that f prime of c equals 0. So it's basically saying that the slope somewhere along the line is 0. And we can see that that's true, like right about there and actually down here, that our slope is 0. We're guaranteed at least one place where that happens. And if you think about it, there's no way, try to think of a way to connect these two places without making a sharp point and without without filling in the holes to where you aren't at least going flat at one point. So you can't like skip around. That doesn't work. Right? They've got to connect, and this obviously wouldn't make a function anyway. You could draw a straight line, but guess what? The whole area is flat. Or you could go down. That works. Or you could go up and down, but you're always going to create at least one place where you have a flat line. And that's all that Rolle's theorem says, is that if these 2 points are on the same y, then your derivative at some point in between them equals 0. So like in this case, we have our value c such that f prime of c equals 0. Now the mean value theorem is much better. The mean value theorem says that, let's say we have, okay, so the mean value theorem says that if we have a function f of x, and just like before, we need it to be continuous on the closed interval a to b, and we need it to also be differentiable on the open interval a to b, then basically what it says is that there exists a value c such that is between A and B such that the following occurs. F prime of C equals f of B minus f of A all over B minus A. So you might think, well, that seems more complicated. And in reality, it's slightly more because this one deals with an infinite number of possibilities as opposed to Rolle's theorem. Rolle's theorem basically said that the 2 points had to be lined up in order for that to work. But notice that the 2 points, basically, all they have to do is share the same slope. Rolle's theorem just says that in order to apply his theorem, that they have to be on the same line. The slope has to be 0. This just says, the mean value theorem says, that the slope at least 1 point in between, I'm sorry, this is supposed to say there exists, that the slope at some point in between is the average. So what does this look like? So think of any function that exists that maybe has a varying slope between places. Does not matter. So let's say we'll just pick these. And we'll say this is A and this is B. So we're looking at the slope between A and B. So just the line. So think about connecting these lines together. Oops, it's really poor. So that is this value. So the difference between the top and bottom of these, because technically B is down here and A is up here. Okay, well, this point is A, f of A, and this point is B, f of B. So the slope between these 2 points, so M is f of B, which is y2 minus y1 over x2 minus x1. And so that's what that slope is. Well, it just guarantees at some point in between them. Okay, so anyway, you can see that the slope of our graph is this right here. And all it guarantees is that if we have a nice smooth curve that touches every point between A and B, then there's going to be some point along the line, so we will say C, that has the same slope as my green line. So, I mean, that's not perfect, but you can see that at some point, the tangent line, or the derivative at this point, has the same slope as the other one. And it's guaranteed it's going to be somewhere in between those 2 points. It's guaranteed. That's what the mean value theorem says. But you have to see that these two things, it has to be continuous and it has to be differentiable in order for this to happen.